kind of refresh your memory on what we did last Friday, a little bit of review of transformations. Different from the parent function x squared, you want to look for, okay, where are these things going to move? Subtract 5 on the outside is going to move down 5. And if you have a -2 on the inside of the parentheses, that's right 2. If you always want to check, you can check on your graphing calculator. So what is the function that would translate the parent function up 3 and to the left 2? That's kind of writing your own function, g of x equals, so up 3, right? That would be a plus 3 on the outside. Then if we're looking for left 2, that's going to be a plus 2 on the inside. Kind of write a function there. We're going to look at a couple more transformations, and it's what does the letter out front of it do? So your a. So in f of x equals a x squared. What does the a do out front? All right. A stretch and compress. If you look at my little dog images here, a stretch is when the slope gets steeper and you're stretched out, like in the morning when you raise your hands to the sky and you stretch, right? And a compression is like in the game Mario when you get smushed by the thing. Reflection, this is a cute picture of my daughter looking at herself in the mirror, right? That's her reflection. And so your a value is going to give you a few of these transformations, all right? If you look at the regular function being this blue line, all right, this blue line here, a stretch then is still crossing over at the same points, being pulled up, gives it a greater slope. And so an a value out front where a is greater than 1, and that's the absolute value of a. It's greater than 1, it gives you a stretch. And your compression is when that a value is between 0 and 1. So kind of think a fraction. That makes the slope less. Okay. So you can kind of go to Desmos and type in a field and see if you can get it to flip around, see if you can get it to stretch, compress. All right, change the number up front and just see if you can figure out what it does. Okay, so take a moment, pause, do that. Look at this. All right, a few things to take note is that if we have a negative a, it's going to reflect across the x-axis. If you were to put the negative right inside the parentheses, right, then it would be a reflect across the y-axis. And if we have our a, right, if we look at this a value, if a is greater than 1, it's a stretch. And if a is between 0 and 1, it's a compression. Just a few things to look at. So these are a couple things to try, right? 3 versus 1/8. See that stretch and the compress, right? Oh, I just wrote this on the last slide. Okay, go back and look at my last slide. So reflection can be over the x or the y-axis, and it really depends on where that negative is, right? So kind of exploring, if we look back, it's either over the x or the y-axis, and think of reflection as like a flip, right? And so what it is the negative is flipped. So if the negative is next to the x, it's a reflection of the y-axis. If the negative is on the outside, so think like over by the y, then it's a reflection across the x-axis. That's one way that I remember it. So see what happens if you put the negative on the outside, right? This one, it comes down here, right? It's a reflection down there. Plus 5, right? I'm showing you this. So plus 5 is going to move it to the go again +5 over here. And then this one is next to the x, so that means it's going to reflect across the y-axis. So then it's actually over here. Okay, kind of cool. So you can see a little bit of the reflections and what they do. Okay. So what is the function rule if we are reflecting on the y-axis? So this would be a negative next to the x. All right, so when I'm writing it, my negative is going to be right next to the x. Everything else stays the same. When I distribute that negative out, it's really just 3x, negative 3x plus 3 is my new function. If instead I'm reflecting across the x-axis, then it's going to be a negative on the outside of the function. So my new rule will be negative 3x subtract 3. So it's a little bit different. It's either on the outside or right next to the x. Combining transformations, we do have to go in order because with the reflection, it's going to make a difference. So if we're trying to get from the 4x as the original function, and first we want to compress. Well, the first thing we want to do to that 4x then is have a multiplier of 1/2. All right, and then I get 2x. All right, and now I want to reflect it over the y-axis. All right, so that means a negative next to the x. That's our new function. So go in order when you're looking at function transformations and combining them together because it might make a difference in your final answer. In that case, it didn't because we were just multiplying. We're starting off at f of x equals x, and we're vertically stretching by a factor of 2. We're going to start by multiplying this thing by 2. Then translate it down 3 units. Subtract 3. What is my new rule? 2x minus 3. So you can combine the things. I always think go in order just in case the order does matter. So what transformations could we do to get from here to there? All right. So think about what can I multiply by to get from 2 to 6. All right, so maybe I'm going to first stretch a 3. Okay, then I need to then 1 to take care of this subtract 1. So stretch of 3, then down 1 would get me to my g of x function. Right? So to summarize, if you want to look at the reflection summary here. The negative is on the outside, it's a reflection over the x-axis. If the negative is on the inside, it's over the y-axis. Okay, kind of a whole thing with that. The stretch or compress has to deal with the a value being larger or smaller than 1, right? The negative is a reflection, so that's different. We're just looking at the absolute value of a value. So this one would be a compression. Happy solving! Do homework. It's on Schoology. Cute quiz tomorrow. There you go.